I'm going to go through the cosine graph a little bit quicker than I did the sine graph because we talked about all the details of what you're supposed to do. Anyway, we're on page 26. If we just pick random values for the cosines inputs here, cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, and cosine of 2 pi, we're back to 1 again. So although the sine and cosine graphs look almost identical, they're just basically the same, but one starts up here at 0, 1, and, which is the cosine, and the sine started at 0, 0. So we know that cosine of pi over 2 is 0, cosine of pi is negative 1, 0, and back to 1 again, and we have the same look, okay, same look. So you got to kind of prepare that turn. And we do the same thing here, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And let's see if I can do this a little bit better. You got to kind of go through there and then start turning. Okay, so there's the cosine graph from negative 2 pi all the way to 2 pi. Okay, for the domain again is all real numbers. We can take the cosine of any real number, the range just like the sine function, and keep in mind that again the cosine is of any point of any angle around the unit circle is equal to the x-coordinate of that point that corresponds to that angle. So we get a point right out here. Okay, it has coordinates x, y, and we know that x over 1. Now 1 would be the radius of the circle, that's why we call it a unit circle, and therefore 1 would be the length of the hypotenuse of this right triangle, and if this is theta here, we have the cosine of theta equaling the adjacent side or leg of the right triangle divided by the hypotenuse. And so the adjacent leg is x and the hypotenuse is 1. That's why the cosine of the angle is the x-coordinate of any point around the unit circle. It's got to be the unit circle. Okay? Okay, so for you just to have the x-coordinate. Anyway, maybe that helps. Hopefully that does. Increasing and decreasing, well, let's take a look there. We can see that this function, again, we're going to list the increasing and decreasing intervals on the overall interval from 0 to 2 pi. This function is increasing from pi. You can see that the y values are getting higher between the x values of pi and 2 pi. Oops. I don't like to put brackets. You can put brackets or parentheses, either one. I like to put parentheses. Decreasing from 0 to pi. Okay. And then, again, just like the sine function, there are no horizontal or vertical asymptotes. And let's see if we can pick the pro style of doing these x-intercepts. We have negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2, dot, dot, dot. So it keeps going. Or pro style would be just pi over 2 plus pi times k, and integer. Okay, k is an integer, so this is the pro way of writing that. Okay, and then the y-intercept we can see is 1. Max is the highest value of the range, and the minimum value is the lowest value of the range. And just like the sine function, the cosine function is periodic. And 2 pi, you can see that every 2 pi radians, the cosine graph will repeat itself. So there you go. All right. Cruising right along here, we've got page number 27, and that's our trigonometric transformation of the cosine function. And we know that the cosine function looks just like, I'm going to put the 1 down here a little bit because I know I'm going to go up 1, 2, 3, 4. So 2, 3, 4, 5. And the cosine graph looks like this, right? Okay, there's a cosine graph. Get a little sloppy when I go to the left, you can see that. So there's the regular cosine graph, and then this plus 4, or 4 plus, that means we're going to take the cosine function and we're going to shift it up, cosine graph, we're going to shift it up 4 units. And so we go 1, 2, 3, 4. The low point here, 1, 2, 3, 4. Okay. This point here would be right in between these guys. So this point here would be right between these. And then this guy right up there. And when we just draw one period of the cosine graph, it's a little flatter, I know, but that's okay. This guy goes up there, this guy goes there, there. So try to make these as neat as you can, you know. Make them look good. Take pride in your work. Don't just be sloppy about it. Okay, so there you go. We can see that the low point here, we should probably put these coordinates so we're clear about this. The low point is 3 and the high point is 5. So we know that the domain doesn't change. Shift it up, down, left, or right. The domain is not going to change. The range, however, does change. The range now, instead of between -1 and 1, is now between 3 and 5 because we shifted the entire graph up 4 units. Okay, increasing, decreasing. So we're going to use the same intervals for increasing and decreasing as the parent function, and the interval for increasing would be from pi to 2 pi. When you shift the graph up or down, it doesn't change the intervals on which the graph increases or decreases. And here we go from 0 to pi. No asymptotes, no x-intercepts. Here, since we shifted it up, it's not going to cross the x-axis, but it does cross the y-axis, and it does cross it at 5. And maximum value is the high point of the range, minimum value the low point of the range, and we still have a function that's periodic with respect to 2 pi. Period is 2 pi. Okay, maybe I can fit in the tangent graph, although that bell's going to ring here in about 2 minutes. Should probably put all this stuff away, but let's see if we can finish this. Okay, page 28. This is the sine over the cosine. And you know, this will take a little bit longer, so I don't want to try to rush this. This is the one that students tend to have a tougher time with than the sine or cosine. So I'll do this one a little bit later, but at least I got you started on pages 24 through 27.